And welcome to this presentation all about QinQ for the platform support on the 6200, 6300, 6400 and the 8360 as part of the AOS-CX 10.10 enhancements. And this is the agenda, an overview of the feature followed by some details and then how we configure on the CX switch platform. So the overview. QinQ is part of the 802.1 AD standard and typically is used by network service providers to segregate customer traffic. But as often is the case, the service provider and the customer may belong to the same business. And this is where QinQ can also assist in segregating local networks and also increase the scalability of the network backbone. So QinQ adds an additional outer SVLAN tag on top of the customer's tagged or untagged traffic. The outer tag is called the service VLAN, known as the SVLAN. So this additional tag provides the mechanism for the service provider to encapsulate the customer's tagged or untagged traffic. And the service VLAN tag is used to identify and segregate traffic for different customers or tenants. The inner customer tag, if it's present, is preserved. And lastly, the SVLAN tag uses the IEEE standard ether type of 8888, and this is the outer tag on the QinQ header. So some terminology to be aware of. CN is the customer-facing network port. PN is the provider network-facing port. CVLAN is the customer VLAN, and these are standard VLANs. And the SVLAN, service VLAN, is the VLAN that encapsulates the customer traffic with the QinQ outer frame header. So let's look at the customer tag traffic entering the provider network via the CN port. So as the customer tagged 802.1q Ethernet frame traverses the CN port on the provider network, an additional tag, the service VLAN tag, is added to the customer's tagged frame as it passes through the PN port. The traffic propagates across the core and reaches switch 3 in this example, where the SVLAN tag is stripped and passed to the customer network port at site B through the CN port, where the original 802.1q tag is preserved. So we need to talk about MTU sizes. So MTU size for the maximum standard Ethernet frame is 1518 bytes. But this excludes the 802.1q tag, which is another 4 byte overhead. And the QinQ tag adds another 4 bytes to the frame. This gives a minimum MTU size to support QinQ with 802.1q tags as 1526 bytes. So a minimum MTU size of 1526 bytes, more if using jumbo frames, is required on each PN port on the provider network. This is an overview of QinQ with an untagged customer frame entering the provider network. Just like the other diagram, switch 1, switch 2, switch 3 form part of the provider's network, and the customer network is connected at the edge. So traffic leaving the customer network at site A, untagged, enters the provider network on the CN customer network port. And as the customer's untagged traffic enters the provider network, it is tagged with a service VLAN as it traverses the end port on the provider network. And this traffic propagates across the core and reaches switch 3 in this example, where the SVLAN tag is stripped and the original Ethernet frame is passed to the customer network at site B through the CN port. Again, we need to talk about the MTU size to support the QinQ 4 byte overhead. As we see, we know the maximum standard Ethernet frame again is 1518 bytes, and we add the QinQ byte overhead and we have a frame size of 1522 bytes. But the customer traffic entering the provider network with no 802.1q tag is likely to be the exception, and the provider network interfaces still need to support 802.1q tagged Ethernet frames as well, and the recommended minimum MTU size is still 1526 bytes, more if jumbo frames are required. And now we go through the detail section. A quick summary of the feature behavior before we get into the topology detail. QinQ support will allow both for service VLANs and customer VLAN configurations on the same switch. This is the equivalent to AOS mixed VLAN mode. And the service tag will use the EtherType 88A8 on the outer QinQ header as part of the 802.1 AD specification. This is unlike AOS where the EtherType can be changed. Note that CN ports, they are actually untagged configuration ports that provide a service tag to a single customer. CN ports can accept both tagged and untagged customer frames. PN ports are tag ports transmitting and receiving service tag frames for multiple customers. PN ports can only accept a service VLAN ID tagged having the EtherType on the QinQ outer header of 88A8. And very important to note for configuration purposes, CN and PN ports can only be a member of SVLANs and not customer VLANs, and we'll review this in the configuration examples later in the deck. And Mac learning is on CN and PN ports is based on the outer service tag. So CN and PN ports will not participate in multiple spanning tree protocol. And MSTP BPDUs will be treated as data packets and will be QinQ tunneled, so do be aware of that. And there are restrictions with loop protect, so CN and PN ports will not participate in loop protect. An SVLAN cannot be a loop protect VLAN, and loop protect packets will be treated as data packets and will be QinQ tunneled, just like the MSTP BPDU, so do be aware. VSF and VSX topologies are supported with PN ports, but there are a couple of things to highlight here. It is mandatory to configure the VSX ISL link as trunk members of only SVLANs, meaning they are PN ports. So the VSX ISL link will act as a QinQ PN port on both primary and secondary VSX nodes, and we'll look at this in a little bit more detail in the configuration section. Ingress and egress ACLs are supported with QinQ. Mirror and S-Flow are supported on QinQ ports, and QinQ tunneling requires an additional 4 bytes in the packet payload, increase the MTU size for PN ports, as we discovered this earlier in the presentation. And because the priority code point incoming on the CN ports is carried forward automatically with the service VLAN. Also, a fixed PCP value can be configured on a PN port, and an example is on the slide here. So let's look at the use of untagged or tagged frames and how they are handled. So the very first important topic to note is that tagged or untagged configurations on the customer network, switches or the directly connected hosts, they must match at either end. If there's a mismatch between tagged or untagged devices on the customer network, end-to-end connectivity will not occur. So the CN port is configured as an access port. It doesn't care whether it receives a tagged VLAN or not, and I'll go through the detail of this in the configuration section. So what this means is that the CN port will receive frames tagged or untagged and the SVLAN tag will be added to the frame as the frame traverses the PN port. Multiple tagged VLANs are supported on the link. To configure a CN port, just add the SVLAN tag, just add SVLAN to the appropriate VLAN configuration, and that's all you need to do. The relationship from the SVLAN to CVLAN is any number of tagged VLANs received on a CN port is mapped to one SVLAN. Or if the upstream switch port is an access port, then it's obviously a direct mapping. Compatibility with other vendors is the prerequisite use of the EtherType 88A8 between provider nodes. Unlike AOS, as I mentioned earlier, this EtherType cannot be changed. SVLAN and gateway restrictions. There are some that we need to be aware of. So an SVI cannot be configured on a VLAN that is configured as an SVLAN. So if we take this scenario where hosts are connected directly to the customer-facing provider node, An SVI cannot be configured on the VLANs configured as SVLANs on the edge provider node switch at either end of the provider network. Of course, gateways can be configured on the customer network for the associated CVLAN, so some consideration is required for the best place to put the SVI VLAN gateway. So what it means is that this connectivity model will not work if we've got hosts on one SVLAN trying to connect to a host on another SVLAN. That will not work because we cannot configure the SVI gateway. So this statement holds true. VLANs cannot be configured as an SVI if associated with a SVLAN. However, there is a workaround. If we have our provider node switch with the PM port and the CM port, we can create a loop between the CM port to a CVLAN port where the SVI gateway can be configured on the appropriate VLAN to support bidirectional traffic flow. So let's take a look at the CN and PN port mix. A number of SVLANs configured directly to hosts or to uplink customer switches, any number of those, and any number of SVLANs can be configured, all subject to the VLAN availability, of course, on that particular switch. And you can have a mix of SVLANs and standard VLANs. They are supported on the same switch. So do note that provider network trunk lag links are dedicated to SVLANs. This means you cannot have SVLANs and standard VLANs mixed on the same provider trunk or lag link. So if you want to extend standard VLANs across your network, you do need to have separate trunk or lag links supporting those standard VLANs. So QinQ is supported in a VSX Square topology. But do note that the PN ports would only carry service VLANs on the ISL links. So the ISL links cannot carry a mix of SVLANs and standard VLANs. So the PN ports will be used as service VLAN links only, which means you cannot carry standard VLANs across the ISL links. So these are the QinQ caveats for 10.10. Note this is the first release of the CX software supporting QinQ, and it will change over the next subsequent releases. We will get more features and more functionality, but this is where we are today. But do note it will change. I'm going to drop down to the selective and transparent features that are not supported today, but will be coming down in the short-term roadmap. So selected QinQ, this feature can add different outer SVLAN tags to a specific or range of inner VLAN tags. Currently, a single SVLAN tag is allocated to all customer tag traffic, as there is no check on the incoming VLAN tag. And transparent QinQ, by default, QinQ tags are applied to all incoming frames with the PVID on a port. This command disables QinQ tag incoming traffic from a list of VLANs. These VLANs are called transparent VLANs. So these features will come down the line. So do take note of that and all the current coexistence constraints with the existing features on this slide. So let's move on to the configuration section. So configure the SVLAN by entering SVLAN under the appropriate VLAN. That's all you need to do. This enables the service VLAN mode where all packets are double tagged if the CM port receives tagged or untagged frames. And you apply this configured SVLAN on the desired CN port, which, although it's using an AOS-CX port configuration, can receive tagged or untagged frames. And then you allow the appropriate SVLANs on the provider trunk or lag links, and that's all you need to do to configure SVLAN for QinQ. So some show commands. So let's have a look at these. So show QinQ. So the show QinQ command is very useful. Highlights all the SVLAN, CVLAN combinations and their role on the switch and their association to interfaces. And the show running config QinQ displays the queuing configuration on the switch. This is an example of an untagged host VLAN connection to the provider service edge switch. So let's take a look at this. So as an example, the customer network presenting is presenting an access VLAN to the provider network. In this example, it's VLAN 10, and this VLAN will be aligned to the service VLAN 200. So on the provider service edge switch, VLAN 200 is configured as a service VLAN. And on the customer network port, the CN port on the provider edge switch is configured for VLAN access 200. And of course, this VLAN 200 is being used as an SVLAN. And the provider edge PN port, the desired SVLANs are allowed on the trunk or the lag port. And as a reminder, you cannot mix SVLANs with standard VLANs on a trunk or a lag link. And if you're using the VLAN trunk allowed all configuration on interfaces or lags, this will not include SVLAN. So you have to manually configure the SVLAN list on a trunk or a lag interface. And on the provider core, I've used an AOS example here on a 3810 switch, and I'll highlight the identical QinQ CX configuration in the next slide. So to configure QinQ on an AOS switch, first you have to turn off spanning tree BBTU throttle on appropriate interfaces and enter the unknown VLAN disable command. In this example, I've used QinQ mixed VLAN mode, where standard VLANs are allowed along with service VLANs on the switch. This is the mode that the CX switches operate when using QinQ. Just note a reboot is required. So native VLANs are non-operational, meaning they do not traverse the PN port. And the last point to highlight is the very important, of course, is to accommodate the QinQ overhead of 4 bytes on each PN interface. Now for the tagged customer VLAN presentation to the provider edge switch using the example of an SVLAN 200 again. So the customer port presentation can be a single tagged VLAN or multiple tagged VLANs on a trunk. In this example, a range of VLANs are tagged on the customer switch and are mapped to a single SVLAN. As you can see, the CN and PN port configurations are identical to the previous example. The CN port doesn't care whether it receives data, whether it's tagged or not, and it maps to the appropriate SVLAN, where it's passed to the PN port, where the QinQ encapsulation is applied for transmission out of the PN port. And if using an intermediate PN node in the core provider network, the configuration required is just to create the appropriate SVLANs and allow those SVLANs on the appropriate trunk or lag interfaces. And it really is that simple. Let's now look at some use case and topologies and some general guidance on how to deliver QinQ. There are a variety of topology options, and this is one of the more common ones, a single switch point-to-point links supporting multiple customers or tenants. And each tenant or customer can position their range of untagged or tagged VLANs, and each customer can use overlapping VLANs, but they will be mapped to different service VLANs. So let's have a look at this. So customer 1 uses VLAN 100 mapped to SVLAN 400, and customer 2 can use the same VLAN and this time mapped to service VLAN 401 in this example. And we can use the same methodology if we wish to use VSF for resilience. And some call outs here. A reminder that additional trunk lag links are required to support standard VLANs across the provider network. They cannot be added. Standard VLANs cannot be added to the provider network ports. And a big one to remember here, the provider network cannot have loops. Only point-to-point links are supported at this time. We do have this feature coming down the line. This is the provider bridge MSDP, PBMSDP 802.1AD, but is not yet supported in 10.10. So do be aware of that. So VSX can be leveraged to support QinQ, and this would be applicable right now to the 6400 and the A360 series. And this may be a requirement if VSX is a prerequisite for the infrastructure, but there are some restrictions. Of course, I think I've touched on these already. Using VSX with service VLANs requires a dedicated PN infrastructure. What this means is that you cannot have standard VLANs going across PN ports as part of the ISL link. So that's quite a big caveat here. So east-west traffic on standard VLANs iCells cannot be a member of those VLANs. So do be mindful of that when you're thinking about leveraging VSX as part of the QinQ provider backbone. And that's all I had for you on this topic, QinQ. Thank you for tuning in.